4-1, inverse variation, and the reciprocal function. The pieces we're doing today and tomorrow, and we'll have a quiz on it on Thursday. These pieces go into the next, and they're important. They're not going to be what you end up doing on your test. You'll probably do direct variation, but you have to know the reciprocal function and the behavior so you can do the rest of what we're going to be doing. Okay, so they're not things per se, like an individual question may be over, but they will. An inverse variation is a relation between two variables such that one variable increases, the other variable decreases proportionally. Okay? Inverse variation, and other thing is we are learning to take notes. That doesn't mean you write every word on the screen, does it? You write every word on the screen? No, you paraphrase, correct? So inverse variation, one variable what? Increases, and the other what? Decreases. One variable increases, the other decreases, and the most important word is proportionally. So that means by the same factor, correct? For two variables to represent an inverse variation, the product of x and y must be constant. What does that mean?
It must equal the same thing.
It must equal the same thing. So how are we going to check for inverse variation?
Do the opposite of what it's doing.
But we're going to do what? What's product mean?
Divide.
Multiply.
Well, yeah. Okay.
We're going to multiply.
You want us to write just the product of x and y?
The product in x and y must be constant. So the question for you, are these two representations of inverse variations? Are we ready to start multiplying?
Yeah.
So 1 times 12 is
12.
12.
12.
12
12. 12 and 12.
and 12. So is this an inverse variation?
Yes.
Okay. One is increasing, the other is decreasing. Do you see that?
Yeah.
Okay, so 1 times 20.
20.
20. 2 times 17.
24.
34.
34. That's what I said.
Oh, okay. 14 times 3.
42.
42.
No, it's 30. That's 42. Hopefully you don't have to think about this one. Or this one. Or this one.
That's not constant.
It is not constant. Now, I'm going to tell you right now, when you went from 1 to 2, you found out it wasn't constant, correct?
Mm-hmm.
Now, should I keep going just to make sure my math is good?
Yeah.
So, like, if I got 20, 34, 20, 20, 20, 20, I probably should go back and check my 34, correct?
Yeah.
Okay? But once I got to, or you could go 20, 34 and check your math. Do I need to finish? No. Okay? If it happens once, it's not constant, it's not proportional, it is not an inverse variation. Now, one variable is increasing, the other is what? Decreasing. So it fit that, correct? But did it have a constant product? No. Make sense to everyone?
Yeah.
Okay, questions? Can I go on?
Yes.
Okay, determine each table represents an inverse variation. So on your own, yes or no?
Do I have to write it out?
It's up to you. You could just write your products on your paper if you want. You have 2 examples written out. They're just, I would write, I'd write your work on there, but I don't know if I'd write the whole thing. It's up to you. You should get yes on the top one. Got 25.5. Okay. And then you should get a no on the bottom. Okay. Again, if you want to stop after the first 2, you probably need to make sure you're absolutely correct. Yes? Yeah, I usually do about the first 3 and go back and check my work. Because we all know that we don't always multiply correct? It took me 3 times to get 25.5 on 15 times 1.7, and I don't know what I was doing. I was trying to
the same thing.
I was trying to do my goofy. But I knew if all of those were 25.5, that last one probably was too, right?
That's what I did. I did the first 3 and then the last one.
You did the first 3 and the last one. No, you should do all of them. Because I wouldn't be surprised on a test like your PACT or your ACT if they put 1 in the middle that causes the issue. And the reason for that is because people will do things like just checking part of them. But on those you'd have a calculator, and it shouldn't take you long to do anyway, right? Questions, guys? No. Okay. When a relation between x and y is an inverse variation, we say x varies inversely as y. Okay, that's just what we say. Inverse variation is modeled by the equation. This one's important. Equations are important, yes? Okay, inverse variation is y equals k over x prime. And actually, it shouldn't be prime, should be x. Or with the equivalent, x equals k over y. How did I get from y equals k over x?
Because they're constant.
No.
Reciprocal.
I multiplied by x. So if I have y equals k over x, I multiplied both sides by x, yes? And divided by y. So x equals k over y. I just moved it around. How did I get y equals k, or xy equals k? Well, multiplied both sides by x, right? So are these any different?
Nope.
No. They're all 3 the same equation. Do not put the prime on the first one. They are all 3 the same equation. K is called the constant of variation. K is the constant of variation. What did we just do on the last 2 slides? What operation math did we do?
Multiplication.
Yes, of what?
Inverse variation.
What? What did we multiply?
X times y.
X and y. Did you just, what was the first constant of variation you guys found?
X, y.
No, what was it?
Oh,
12. What was the second constant of variation that you found? 25.5. It was 12 for that first one, 25.5 for the second one. So if it wants the constant of variation, you multiply x times y. Why can't k equal 0? Variation means it varies, yes? Okay, 0.
Well, wait, it says that you have to have.
It says right here.
It has to be increasing and decreasing, so therefore you can't have it increasing 0 and decreasing 0. You can't do 0.
Right, but the only time you'd be able to get 0 is if one of them was always what? 0. Okay? Doesn't make it for proportion, does it? So, again, you have the 3 inverse variation models you should have down. You should have K is what? Constant variation, and you probably want the side note that K can't equal what? 0. So, did I write all the words on that slide?
no.
No, you should not be. If you're writing all those words, your brain is like,
Does it mean it can't be
much stuff.
one then?
It could be, it
says it has to.
could be 1, but it doesn't. If it's 1, I guess then they're negative reciprocals of each other. It's just weird. It usually is not 1, but it can be. It just can't be 0
Oh, yeah.
because 0 is no change. Am I good? Okay. In an inverse variation, x equals 10, y equals 3, write the equation that represents the inverse relation. Okay. So then find the value of y when x is negative 6. Okay. So remember, an inverse variation is y equals what?
Y equals k over x.
K over x, right? So I need to figure out what do I need to figure out? An equation has an x and a y in it, yes?
Yeah.
I need to figure out what k equals. K is what? What's the name for k?
Oh, it's the constant variation.
The constant of variation, okay? So how do I find the constant of variation?
X times y.
X times y. If you move this equation around, do you not get x times y equals k? Okay, so k equals x times y. So what was x?
10.
And what's y?
3.
3. So I have 10 times 3. So k is 30. So the equation, the first is write the equation, right?
Yeah.
So I have y equals, what's k? 30 over, nope, x. Okay, this is our equation. All we need to do is calculate k. So that's the first part. There's our equation. And then it says what?
The value of y.
When,
Y equals -6.
so we do what?
30 over
Y.
We plug in -6 and divide and get y equals what?
-5.
-5. So they gave us a lot of information, but did we use it all at one time?
Yes.
No, we did not. Yes, Blaine.
Then why does it say y equals 3?
Okay, it starts with x equals 10 and y equals 3.
Yeah.
Okay? It gives you that. And it says write an equation. So with that x and that y, I could find the k. So
those
this-
don't really matter at the beginning.
No, it's like a point on an equation. Like if I gave you 2 points on a line and said write the equation, you got to find the slope, you have to find the y-intercept.
Oh, yeah.
It's the same thing. Okay? So the equation, the inverse variation equation is y equals kx. And all equations have an x and a y in them, correct?
Yeah.
Yes? Like y equals mx plus b. You have to find the slope and the b, but you're still going to have an x and a y. So we had to find the constant of variation first. So again, an inverse variation, x equals 6, y equals 1/2. Write the equation and find the value of y when x equals. Could they say find the value of x when y equals? Could they do that? Yeah? Okay, so the first thing I need to do is find what? K. K equals x times y. I would suggest writing that on your paper today. Okay, what's x? 6. What's y? 1/2. Half of 6 is 3. So my equation is y equals 3 over x. So that's the first part. And what's the next part that I do?
Y equals 3 over 15.
So y equals 3 over 15. So y equals 1/5. So if I had a table of values like they handed you the first time, right? They had 6 and 1/2, correct? And we would have 15 and what? 1/5? Okay. Is x increasing? Is y decreasing? Yes. 1/5 is smaller than 1/2. Make sense? Questions? Concerns?
Are we gonna have to make a table like on
I don't think so. But if they ask you to, if they ask you several X's, you could just make it in a table form.
This is a type of math.
And that's it for today.
So, what, really?
Okay,